Whenever you are adding and subtracting fractions, you need to have a common denominator. And the key skill that we want to learn is how to find that common denominator. Before we go any further, however, let's go back and review a basic problem from arithmetic that does not have variables in them at all. Let's say we want to add 7/8 and 3/5. We look at these fractions and we ask, okay, what is the common denominator? In other words, what do both 8 and 5 both go into? And the answer is they both go into 40. So we write that as the common denominator. Then to convert these fractions, we need to multiply by something to write it in an equivalent form. Well, to go from 8 to 40 in the denominator, we need to multiply by 5. So we multiply by 5 up above in the numerator also, and 7 times 5 is equal to 35. 7 over 8 is equal to 35 over 40. They are equivalent fractions. We've multiplied by 5 over 5, which is equal to 1. And anytime you multiply by 1, the value of what you have is equivalent to what you began with. Now, in this second fraction, the denominator changes from 5 to 40 because we're multiplying by 8. So we multiplied the 3 by 8 up in the numerator also, and that gives us 24. Now we can add together and get 59 over 40. Now we do not use mixed numbers in an algebra class, so we will leave this as it is, as an improper fraction. Now these skills that we've just done, even though it seems rather basic to us, these are the same exact processes and that we go through when we are adding algebraic fractions. Now let's concentrate on the skill of finding the least common multiple. I need something that both 5x squared y cubed and 6x to the fourth y go into. It turns out that the least common multiple is going to be 30, because 5 and 6 both go into 30, x to the fourth, y to the third. Now, for the x's, I looked at the x squared and x to the fourth, and I took the larger of the exponents. Same thing with y cubed and y. I took the larger exponent. Now, I didn't want to do just that because it's an important skill to be able to answer how our terms have changed when we've multiplied to go to this least common multiple. To go from this original 5x squared y cubed, we've multiplied by 6x squared. And this second term, 6x to the fourth y, has been multiplied by 5y squared to get to this least common multiple. Now, why do I pay attention to what I've just put in there next to those arrows? Well, the answer is I need to be able to, 1, verify that this is a multiple, and number 2, when it comes to adding and subtracting fractions, we're going to have to be able to identify that fact, just as we did up above with the 5 and the 8, to be able to convert our fractions to be over a common denominator. On number 2, I noticed that we don't have single terms. We have binomials, and what we want to do is factor each of these first. 3 factors out of the first expression, and the second expression is the difference of 2 squares. We will look at these factored forms to determine what the least common multiple is going to be. Now 3 is the only leading coefficient, so that needs to be in our least common multiple, and this first expression says x plus 2 needs to be part of our least common multiple. The second expression says, okay, x plus 2, I can get into that, but there needs to be an x minus 2 in it also, so that I can go into it as a multiple. So now, what are we multiplying by to go from the old to the new? This first expression had the 3 and the x plus 2. It got multiplied by an x minus 2. And this second expression got multiplied by 3 to go from one form to the least common multiple. In number 3, again, we're going to factor first. Take a 5 out to have x minus 2. Take a 10 out to have x plus 3. The least common multiple is going to be 10, because 5 and 10 both go into 10, multiplied by those 2 factors, x minus 2 and x plus 3. Now, this first term, 5 times x minus 2, is getting multiplied by a 2 to go from 5 to 10, as well as an x plus 3 to get to that least common multiple. This second expression already has the 10, already has the x plus 3, so it's getting multiplied by x minus 2. In number 4, we factor the first expression to become x minus 3 times x plus 2, and the second expression to become 3 times x minus 3. The least common multiple will need to have that leading coefficient of 3 in it. It will also need an x minus 3 and x plus 2 so that the first expression can divide evenly into it. This first expression is getting multiplied by the missing 3, and the second expression is getting multiplied by the missing x plus 2 to go to that least common multiple. In number 5 here, there is no factoring that is possible, and we do not look at the 2 and 4 and say they both go into 4. We treat these as separate terms or expressions altogether, and the least common multiple will actually be the product of these two expressions. So this first x plus 2 expression is getting multiplied by x plus 4 to go to that least common denominator, or least common multiple I should say, and the second one is getting multiplied by x plus 2.